In this topic, we move beyond issuing individual certificates and focus on running them as a system. You'll see the full lifecycle end-to-end, common failure patterns, and the core concepts behind CLM platforms that keep your organization's engine of trust running reliably at scale. Manual certificate tracking usually starts with a spreadsheet and good intentions. Then one entry is wrong, or a temporary shadow certificate never gets recorded. With no central monitoring, the renewal window quietly passes. The cert eventually expires or gets reissued with the wrong EKU or subject, and nobody notices until something breaks. The real cost shows up as an application outage, emergency fixes in the middle of the night, and potentially a failed compliance audit. Treat certificates as living assets, not one-time installs. Each one moves through a life cycle. Someone requests it, it's approved, issued, and then deployed to an application or device. From there, the ongoing work begins. You monitor health and usage, renew before expiry, and just as importantly, revoke and decommission it cleanly when it's no longer needed. Mature PKI engineering is about orchestrating this loop at scale, with automation and clear ownership at every stage. A healthy PKI starts with knowing who owns what. Application and service owners own the business need. They request certificates, define requirements, and verify that deployments actually work. The PKI team owns the platform. They manage CAs, design and secure templates, integrate CLM tools, and keep issuance predictable and auditable. Security and audit functions own the guardrails. They define policy, approve exceptions, and ensure you can prove compliance. Clear boundaries here prevent orphan certificates from silently expiring in production. A useful way to see CLM is as a control plane wrapped around all your certificates. At the center is the policy engine. It decides who can get which certificate, with what key strength, and under which approvals. Feeding that engine, discovery agents continuously scan networks, clouds, and endpoints to find every certificate in use. Enrollment gateways centralize issuance from both internal and public CAs. Finally, connectors push certificates and keys out to web servers, load balancers, and key management systems. For any serious PKI program, discovery and continuous inventory are non-negotiable. You need to know every certificate, where it lives, who owns it, and when it expires. You get that visibility from two directions. Active scanning probes your network and TLS endpoints, catching unknown or shadow certificates. Passive ingestion pulls data from CA logs, cloud APIs, and CMDBs. All of this has to land in a single source of truth. So you can track expiry, key strength, and policy compliance, and drive automation with confidence. Policy-driven management means you don't treat every request the same. Each one runs through standard gates before it ever hits a CA. First, you enforce key size and algorithm standards, so nothing weak or deprecated gets issued. Then you restrict subject and SAN formats, plus validity periods to what your organization approves. Finally, you add extra checks for sensitive use cases, like code signing or admin access. The outcome is consistent, compliant certificates, and far less configuration drift. Not every certificate request should follow the same path. With risk-based workflows, you classify the request upfront. A low-risk, standard internal TLS cert that matches policy can be issued automatically with zero human touch, so app teams get it in seconds. Higher-risk requests, such as external endpoints or code signing, follow a different lane. Multi-step human approval, routing by environment, and full auditing. You're aiming for speed on routine requests and strong governance for anything that could really hurt you if misused. CLM maturity tends to fall into three operating modes. In a manual world, certificates live in spreadsheets, renewals are ad hoc, and outage risk is high because everything depends on people remembering dates. In a semi-automated world, teams add scripting and some scheduling. Risk drops, but coverage is patchy and still fragile when ownership changes. Fully automated CLM couples discovery, issuance, and renewal with integrations into your CA, load balancers, ITSM, and cloud platforms. The target state is minimal human error, predictable renewals, and complete visibility. In a mature CLM platform, different stakeholders experience PKI very differently than before. Security teams see looming expirations by business criticality, not just by date. Risk teams get instant views of which algorithms are still using SHA-1 or short RSA keys. Auditors can drill into a specific certificate and answer in seconds who approved it, when it was issued, and exactly where it's deployed. Once PKI is integrated with ITSM and change management, certificate events stop being surprises and become normal, trackable changes. The CLM tool detects an upcoming expiry and automatically raises a change ticket. That ticket then follows your standard CAB review, approvals, and SLA checks, just like any other production change. In parallel, the CMDB stays in sync, so each certificate is tied to a real owner and configuration item, giving you clear accountability and auditability. Modern PKI design has to span 4 overlapping environments. On-premises, you're dealing with traditional web servers, load balancers, and agents that can run full-featured clients. Patterns here are mature and policy-heavy. Cloud-native workloads expect API-driven issuance, close integration with Key Vault or other secret managers, and often service mesh MTLS. DevOps teams need short-lived automated certificates wired into CI/CD, not ticket queues. And IoT or edge scenarios require highly scalable enrollment gateways and very constrained device identities, often with limited crypto capability. Resilient PKI design starts from the assumption that some component will eventually fail or be taken offline. Rather than relying on a single CA and a single CLM platform, you design for multiple CAs and redundant CLM gateways that all enforce the same policies. Normal traffic flows through centralized policy engines, but you also predefine an isolated break glass issuance path for emergencies. The objective is controlled redundancy, strong central governance with local automation and alternative issuance routes when things go wrong. Use this path as your practical rollout roadmap. First, assign ownership. Every certificate needs a clear business owner and lifecycle expectations. Next, establish visibility. Use policy-driven discovery and monitoring so you actually know what exists, where it is, and how it's used. Then begin automating, but be selective. Target high-risk and high-volume areas first to prove value and reduce outage risk. Finally, wire PKI automation into ITSM and audit, so requests, changes, and evidence are fully governed, repeatable, and easy to demonstrate.